我们今天的主题是 Reactive Contracts，然后大家可以先把 Zoom 调成静音，有问题也欢迎就是提前发在聊天区，我们会在后面 Q&A 的环节集中整理给 Even。Good evening, everyone, and welcome to tonight's workshop. Thank you all for joining today's workshop. Please feel free to settle in, and if you have any questions during the session, you can drop them in the chat box at any time. We'll collect some of them for the Q&A later. 然后我是今晚的主持人 Zoya，也是 Reactive 中文社区的 Ambassador。今天我们主题是 Reactive Contracts，也就是深度拆解终极代码案例。也很高兴今晚能邀请到 Reactive Network the Head of Developer Relations Evan，然后来为大家分享。今天这场的 workshop 也是希望带大家从更深入的案例出发，进一步理解 Reactive Contracts 的开发方式。在分享的过程中，就是大家可以把问题发在聊天区，我也会帮大家收集，并在 Q&A 的环节要统一让一文为我们讲解。Hello everyone, I'm Zoya, the host of today and also an ambassador of Reactive Chinese community. Our topic tonight is Reactive Contracts, a deep dive into an intermediate code case study. We were very happy to have all of you here with us. If your previous session was more about helping people to get started faster, then tonight's workshop is about going deeper, understanding not just how reactive contracts work, but also why they are designed this way and how to think about them in actual development practice. It's also my pleasure to introduce my guest speaker today, Ivan, the head of developer relations at Reactive Network. In tonight's session, he will walk us through an intermediate level code case and help us explore the development patterns, logic, and design thinking behind the reactive contracts in great depths. Even the stage is yours. You can begin.
Yeah, thank you very much. Hello, guys. Happy to be here with you today. And let me start sharing. First of all, I start with the slides, right? Give me a moment to share my screen. Yep. I will probably take a look at the whole screen right away because we will need both the slides and then the code editor, right? But let's start with the slides. So yeah, the topic of today's workshop is advanced use cases. Honestly, they're not that advanced. It's just that, as stated earlier, we're going to be discussing some of the actual development practices, and we will use some of the a bit more complex code examples as a showcase. The agenda, for some reason it's not, the agenda for this discussion is first, I'll remind you guys of the context. Then we will discuss the economy of working with reactive contracts and callbacks. I'm not talking about the company tokenomics here. I'm talking about how the callbacks in the reactive network and on the destination chains are paid. Right. Then we'll discuss the dual state environment. I believe we've discussed it already on the first workshop, but back then you didn't have enough context and experience. So I want to go over this topic once again. And then we'll jump to code examples. We've already discussed a basic example on our previous workshop and co-learning session. Today, we'll take a look at the cron example to set up regular actions, and we will take a look at the most practical, from my point of view, example, which is stop order. So for the context, let me remind you that reactive smart contracts allow reacting to on-chain events with on-chain actions on the same or a different chain, which enables automation, where you react to actions on a contract with maybe actions on the same chain, but on different contract, or on the same contract. That means you won't need any off-chain bots or manual actions. You can rely only on on-chain logic, which is cool. Also, reactive contracts allow for cross-chain functionality where you react to events on one chain with actions on a different chain, which can be useful for a bunch of applications, starting with Bridge, cross-chain Oracle, cross-chain lending, and many other things, whatever you keep in mind for your cross-chain setup. And then reactive contracts allow for modularity, and I ask you to keep that in mind also, where modularity is the ability to build on top of existing contracts, be it your own contract that you don't want to change or update, or be it third-party contracts over which you don't have control, so you only can build on top of them, reacting to their events, right? And all of that in a decentralized manner on chain. And yeah, also I wanted to remind you of this scheme here, because this is the basic scheme. It makes sense to keep it in mind whenever we are taking a look at any code examples. I've shown it a bunch of time already, but yeah, normally we have an origin smart contract on the origin chain, then a reactive smart contract that reacts to some event on the origin contract, and it executes some logic, does some checks, and as a result, it might or might not emit a callback to the destination smart contract. So this is the basic thing. It will be present in all of the examples that we discuss later. I wanted to remind you of this context just for all of us to be on the same page. And now let's discuss the economy. So we'll be taking a look at code examples for that matter as well. But let us start with the docs, because obviously you might not be able to remember everything I will be talking about today just from the Zoom call, right? But you will always be able to take a look at the docs. And generally, I don't remember, and honestly, I don't remember all the details myself. So obviously, I'm also taking a look at the docs sometimes. Uh, yeah. So economy in that context is how we are paying. Yeah. Also, feel free to ask the questions in the chat anytime. So that's not like a lecture, that's a workshop. And whenever you have questions related to what I'm describing, please feel free to ask them, because the point is not just to go through some content. The point is for us to form an understanding on your end of what's happening here. And if you don't understand something makes sense, make sure to ask questions, because basically I'm here to answer the questions more than to go through the docs, right? But yeah, the docs will be just a small part of what we're discussing today. It's just that the economy part is described the best there, so it does make sense to copy paste it to the slides, right? So yeah, basically I won't be reading this text. You can go over it later after this workshop if you're interested in details, but I will use it as a slide, so to say. So there's at least there's two types of things we're paying for in a reactive contract. So remember the scheme, right? There is an origin contract, a reactive contract, and a destination contract. Origin, it happens by itself. Someone else is running a transaction and paying for that, so we're not paying for that. But we are paying for the reactive contract execution and then for the callback execution, right? So here's the description for RVM transactions, and also callback pricing here, right? So for RVM transactions, we only pay when a reactive contract is executed, right? And the reactive contract is executed whenever there is an event to which we've subscribed that fulfills the initial criteria that we set up in a subscription, right? Because after that, we might want to check something else, like what was the price in that sync event, what was the size of the transfer, right? All those additional checks, they're happening within the smart contract, the reactive contract. We will see it later. And we pay for them because at that point, the reactive contract is being executed, right? But the initial checks are what chain we are on, what is the smart contract address, and then what is the topic zero of the event, right? So basically whether this specific event happened on this specific contract on this particular chain, right? So if those three conditions are met, then the reaction is triggered, the reactive contract is being executed, and we pay gas as in any EVM execution, right? So here you can find the formula for how this payment is calculated, right? And then we also need, like, what we need right now from the um, hackathon perspective, from the learning perspective, right? Like, I don't think we really need to calculate how much gas we will be spending, because we can always just try and see and then get more testnet tokens, because we're not paying for those tokens, right? But we need to make sure we understand how we top up the balance of the contract so that it actually executes, right? So for a reactive contract to be executing, it has to have funds, right? And that's how we fund a contract. There's several ways of doing so. Reactive contracts must be funded in React before executing RVM transactions. Normally, when you deploy a contract, and we have that in our examples, you credit it with some React tokens and ETH in the case of callbacks right away. We'll see that in the code examples. But yeah, you might run out of that, or you might add additional funds. So that's how it's done. Basically, just cast send to the contract address as you would send to any other address, right? Then also, if the contract has already ran out of money and there was some reaction that didn't have enough money to be executed, then this contract is in debt, and you have to cover this debt by calling um, the cover debt function, right? So that the system contract knows that you've provided some funds to your contract and the debt is covered, right? Um, Yeah, but that's how to do it through a contract, through direct transfers. The other way to do it, and you might choose the one or the other way based on your preference or based on the details of your setup. But yeah, there's also a way to do it through a system smart contract. Contract can be funded through system smart contract using deposit too. The sender pays the transaction fee, and the and any outstanding debt is settled automatically. Maybe like this way is easy because you only need to call one function, right? Because here, if you've got into debt, you need to send some funds, then check whether you're in debt, or just call cover debt function, right? You might prefer just to call this function. In that case, you don't need to check whether you're in debt. You don't need to do two calls, just one call. You call the deposit to function on the system smart contract, where you provide your contract address as a parameter, right? All those variables, they stand for environment variables that you have set up in your operating system, right? And like those values, this is, you can find them here in origins. Yeah, here probably. Yeah, so this is for mainnet. This is for testnet, the RPC, the chain ID, all that stuff. This is your private key. This is the system contract address, which can be found here, right, for all the mainnet chains, and this is for the testnet chains, right? So in your case, it most probably will be this one, right? For reactive network, and this one for Sepolia. And then, yeah, let me do it like this. And then this is the address of the contract that you deployed, right? And here you pass the value of Ether that you want to credit it with. Ether meaning React in that case. Okay, so this is how you pay for reactive transactions. right? And this is for the callback contract. So this is the formula. These are the values. We won't be discussing the values right now because we're not working on the mainnet and not spending any real money. And for the testnet, you can just try and see, and you might even use it as an exercise to calculate, to find out those coefficients, right? Based on the gas you spent and other stuff. But yeah, generally it has the same payment model as RVM transactions. So you can use direct transfers or you can use transfers through the system contract, right? Also make sure to take that into account that Reactive Network enforces a minimum callback gas limit of 100,000 gas. Callback requests below this threshold are ignored as this minimum ensured sufficient gas for internal audits and computations required to process the callback. Yeah, so for direct transfers is the same as for RVM, and also the cover debt functions works the same way. We'll take a look at the contracts later because when you're developing reactive contracts and building callback contracts, our recommendation is to use our reactive lib, which is a library of simple base for your smart contracts where all this stuff is implemented, right? Where you have the cover debt function and other useful stuff. And yeah, all of our examples, they use this library, so you can just follow what our examples are doing, right? Okay, and the same for deposit too. Yeah, also on the spot payment is available implementing pay or inheriting from abstract payer, which is a part of the lib that I've just mentioned, enables automatic settlement. The callback proxy calls pay when a callback creates debt. The standard implementation verifies the caller, checks, balances, and sells. So yeah, you might want to use this stuff as well. Um, Yeah, and also you might need to be checking those balances, right? You might want to, you can implement some kind of a backend solution to monitor them and pay or some other thing. But yeah, you will be using balance and you will be using this debts function here. And this reserves function here. So this basically all refers to the functions implemented in our library. So we will take a look together, and I suggest that after the workshop or when you build something, you take a look at this lib. It's not a lot of lines of code, so it makes sense to read all of them, I believe. That's doable in like half an hour or even less with the help of AI. Yeah, so I will be just repeat. Yeah, this is the same stuff for reactive. So yeah, this is how the economy works. Basically, to sum it up, you need to pay for reactions and for callbacks, and here you can find how to do that. Okay, so we've discussed this point here. Let's also discuss this point here, which is dual state. Right. So also I will share these two slides and then I will share the docs as well. So as you might remember, for the parallelization purposes, we've created RVMs and reactive networks. So there's a duality where each reactive contract is deployed in two instances. An instance on your own React VM, which only you can basically work with, and then the reactive network instance, which is as a usual Ethereum smart contract. So mainly you will be working with this one, but you can also use this one as well. But mainly you're interested in that one. So they have small differences, and the main difference is that they have different state. One state for this one and one state for that one. Make sure to remember about that when you're working with the state of a reactive contract. make sure to understand which state you're working with right now. In most cases, you will be working with this one. And here is the difference. So first of all, the React VM instance, it's triggered by events. So whenever you implement a reaction, whenever you monitor events and then react to them with a reactive contract execution, it's here on RVM, React VM side of things, right? So the reactive network instance is not triggered by the events. Also, correspondingly, the state, the values of the variables you use in your reactive contract, they're updated based on events here. They're not updated based on events here. So let's say you implementing some kind of counter that counters maybe how many transfers this particular account has done, and you will be triggered by every transfer, and you will be counting them. So this counter will be changing in the React VM instance. It won't be changing in Reactive Network instance. Also, this thing here, it emits the callbacks. So all the actions on the destination chain, they're done by this thing here. You cannot use Reactive Network instance for this purpose. It cannot emit callbacks. Then this thing here, the React VM instance, it can only be triggered by an event. It cannot be triggered directly. And this is the main issue the developers run into when they start working with reactive contracts, is that they try triggering React function manually for debugging purposes, and it doesn't work that way because it cannot be triggered directly. It lives within a React VM, and when you do a direct function call, right, you're interacting with reactive network instance, right? So, for instance, the dat function earlier, it was related to reactive network instance, not to React VM instance, because we call in the function directly, so it's here, not here. Then this thing here, it cannot subscribe directly. So if you want to implement so-called dynamic subscriptions, right? When you subscribe to a new event based on the previous reaction, you need to react to an event and then do a callback to this reactive network instance of the contract. I won't dive into a lot of detail here, but yeah, you can take a look at some of the examples and you can ask questions. I'm not sure you will need that dynamic subscription thing in your setup, but if you do, please feel free to ask questions or maybe ask them tomorrow on the co-learning session. If you try to implement that and fail, let me know. I will explain how to do that. But most probably you won't because it's only used for some pretty specific use cases. Okay, and here you can subscribe directly. So if you want to add subscriptions to your contract, you can implement some function that will add those subscriptions and call them here, right? And here you can subscribe using callbacks, as I have said. So you can be triggered by an event, and then you can send a callback to the reactive network instance of the contract. So basically to this very contract, but on reactive network. Okay. Yeah, let me take you to the docs now. Show the part that's related to this thing here. Yeah, React VM. So here you can read more on the same topic. It talks about what I've just described, the dual state here, right? A separate state on React VM and reactive network. It explains how it works under the hood as well. Okay, so the next thing I wanted to mention, and yeah, I've already mentioned that before, but you might not have enough context back then. So um, since it's a learning process, I think it makes sense to reiterate over some things that are important and might be not as simple. That's one of them. So when we are working with reactive contracts, we implement callbacks. So some actions done on the destination chain, right? And a callback, it's called by a reactive EOA, externally owned account, through the callback proxy contract. right? But if you do not implement any type of authorization on your callback contract, that means that anybody will be able to call that callback function because that's how Ethereum smart contracts work, right? Anybody, like if you don't implement authorization explicitly, that means this function can be called by any uh, address, right? So let's say we're implementing a stop order where our callback function is the execution of our order, right? We don't want anybody to be able to trigger it. We only want it to be triggered by a reactive network, right? And only by our reactive contract, only when the predefined price is reached, right? So that's why we implement authorization the following way. First of all, we need to check the sender address, make sure it's the correct one. And by correct one, I mean the callback proxy address, right? You can find callback proxy addresses here. Yeah, callback proxy. And you want to implement the check that your message sender is this address for Sepolia, right? But then this works so that only reactive network can call your callback function, but you also want to make sure that it's only your reactive contract that calls that function. Because if I was an attacker, I could implement a reactive contract that would, on behalf of reactive network, call your callback contract and execute your logic, maybe at the moment where you don't want it or with the parameters that you don't need, right? So you also want to make sure that it's your reactive contracts that are calling your callback function, right? And for that purpose, you check the first argument in the callback and make sure that it's your RVM slash deploy address. It's slash because it's the same thing. Your RVM address is the address from which you deployed your reactive contract. We will see it in the code examples. But yeah, in case you want to implement any type of security, that's how you do that. And I suggest that in your reactive in the callback contracts, you do that because otherwise it cannot be considered, definitely it cannot be considered a production solution without authorization. But also, if you're talking about a hackathon submission, you might want to show that you understand how things work, and that's why I suggest that you implement that stuff as well. Because yeah, there are some more complex things like dynamic subscriptions and other things, but this thing is not complex, and you definitely are recommended to do that in your contracts. Yeah, and I believe we have something about that here. Yeah, but I don't remember where. But we definitely have that in examples. So if you follow our code examples, you will be good. Okay, so we've discussed economy, we've discussed dual state and for authorization. And now it's time to go to code examples, right? So today we will go through at least two code examples, maybe three. Yeah, and please make sure to ask questions because most probably you will have some questions. And like if we don't have any questions, it doesn't really make sense to go to a more advanced example. Right? Because generally, because we want to interact here. I cannot make sure you got everything right unless you ask questions and yeah. Yeah, by the way, let me take a look at the chat. Maybe we already have some. No, not yet. Okay. So let's go to the cron example. I will be showing it in my IDE, but generally, yeah, this is the repo. You'll like if you just go to Reactive Network and go to GitHub here, you'll get to the right place, right? So here we are at the right place in our examples repository. First of all, let me remind you of the structure that we have here. right? You can use the README because it exactly describes the structure. It explains what's happening here. We have some list of demos here. So the basic demo we've already discussed in the first workshop. Then a cron demo we will be discussing today. Hyperlane demo we won't need for the purpose of our hackathon. Uniswap stop order demo we will be discussing today. And this is the same thing, but with more advanced implementation. We might discuss it today if we have enough time and we have enough interest. And then these things, they're good. I suggest that you take a look at them yourself. We definitely won't have time for this. Okay, so let's start with the cron demo, right? I prefer to show it in my IDE because it has a dark theme and other cool stuff, right? Okay, so here I am in Reactive Smart Contract Demos repository, right? And SRC demos folder, and we were discussing the cron demo, right? So basically, it's a very simple thing. It's even, I would say, it's simpler in a sense than the basic demo that we've discussed earlier, right? So in basic demo, we got three contracts, which is the origin contract, this one, the one we are monitoring, the one that wasn't left on our scheme, right? Then the reactive contract, and then the destination contract, right? The one on the right. In cron, we only have the example of the reactive contract. But yeah, it's enough for that demonstration. So let me show you what's happening here. Like, first of all, you might want to take a look at the lib, because as you can see, this basic cron contract is inherited from abstract posable reactive, which is a part of the lib we discussed earlier. So yeah, let's take a look at this thing here. It's rather simple, but it's important. So that's why I suggest that we take a look. Yeah. Abstract posable reactive, right? And this one in turn is inherited from abstract reactive, right? Yeah. So what happens here? It has the pause function, which unsubscribes here, and resume function, which subscribes back, right? And that's it, more or less. But what we're more interested in is this one, because obviously, like, when you inherit our contract from this, and this is inherited from this, all stuff from here gets to our contract, right? So let's take a look at abstract reactive. Mm, okay. We don't need all the stuff here, but we do need some of the stuff. Basically, I think we need this one, abstract payer, because I wanted to mention how the payment is executed. But yeah, as you can see here in abstract reactive, it not subscribes, it specifies the reactive ignore constant, and it specifies the service address here and adds this as an authorized sender, right? And also, these are the functions to distinguish between React VM and reactive network instances that we've discussed in the context of state duality, right? But yeah, we're interested in this thing here. And abstract pair, as far as I remember, let me see here, abstract callback. Yeah, this is also inherited from abstract pair. So this part we're discussing here, it goes both to reactive contract and your callback contract. And this is how payments are implemented. I wanted to show this because that's what we discussed today. And it makes perfect sense when you have some simple code that implements the stuff you're talking about, to take a look at this code so that, we have all the dots connected. I've shown you the slides, I've shown you the docs. Now we're taking a look at the code which implements this stuff, right? So yeah, as you can see here, we have this cover that function. that we've discussed earlier, right? It takes a look at the debt and then it pays it, right? Then the pay function, it checks the funds. Then if the amount is enough, it's actually executes the payment, right? And also we have a thing that adds or removes authorized sender, and we have the modifier whether the sender is authorized, so only for authorized sender. Um, yeah, so if you want to understand it, I suggest that you go here. I've shown the basic stuff, but if you want to understand specifically how it works, you need to go through it with your own eyes. It won't make a lot of sense for me to go line by line and explain it because, yeah, with code, it's better to take a look yourself, scroll yourself, and obviously ask AI because, yeah, let me take a look here. So here in this tab, as you can see, I'm asking my Claude to explain this thing to me, right? You can follow this similar workflow, right? Do you see this repository? I'm talking about the improved, the advanced stop order here. I'm giving the context that it's reactive contracts and providing it with the link, and then I ask to explain it. It does some fetching and explaining, right? I hope it's correct. I didn't read it, but yeah, then you might, then I believe I have some additional question here. Yeah, so here I ask to break down create stop order and execute stop order functions. You might want to do the same. So for every line of code that you don't understand, you can ask, please break down, please explain. I suggest that you do that in case you don't understand something. I think AI is great with explaining those kind of things. Though sometimes it's wrong and it makes sense to validate all the output yourself, make sure you understand it, and if you think it's wrong, and then it might be. Okay, but I just here I didn't want to share any technical details. I just wanted to remind you that you can always ask for explanations. Obviously, you can ask me on this workshop, but then at some when you're working on the stuff yourself, you can ask AI. Right? So we've discussed this abstract pay here. You might, when you start building, I suggest actually that you dive into that simple contract and understand it line by line. But yeah, now we were discussing the cron demo. And yeah, so it's inherited from this one and goes to abstract pair. Yeah, okay, so what's happening here is we are subscribing to mm, cron events, right? So we are passing in the constructor the topic of cron events, then we are subscribing to them here, right? We are subscribing to them like normally here would be the address of the contract that you are monitoring, right? Your origin contract. And here would be the chain ID of your origin contract, like Ethereum supporter, for instance, right? But here the chain ID will be reactive network and the address of the contract will be a service contract because that's the one that emits those cron events. And cron events are the events that are just happening regularly. So if you want to implement automation not based on some event on the external contract on Sepolia, but a time-based automation, that's how you do that using this cron demo, using the cron events, right? This part we don't need right now. Yeah, but this is the important part. This is the reaction that happens when those cron events are executed, right? So here would be your actual callback. So since this is a simple example, we don't have a complex callback here. But yeah, this is where your callback would be. And also let me take a look at the demo because it should like obviously it explains all the stuff that I'm talking about here, but also it should provide the some details on the cron topic, I believe. Right, let me take a look. Yeah, so an event enabling time-based automation at fixed block intervals, see reactive docs, cron functionality. Let's go here, by the way. Yeah, it's a reactive library, so you might want to check this part in the docs as well. Cron functionality here provides the topic 0 you're interested in. So in case you want a reaction every block, which is every 7 seconds, then you use this thing here every 10 blocks, this thing, and so on. Like obviously, if you want like something in between, you just use the combination of those, right? For instance, uh, 2 hours plus 3 times 12 minutes, and so on. Also, keep in mind that those are not strict times, it's approximate times, because it's blockchain. It does not have, and in Ethereum it works the same way. It does not have direct access to a clock, right? To time. It only has access to the block number. And then with blocks, they go out on average every 7 seconds for reactive and every 10 seconds for Ethereum, and different block time for every other blockchain, but a predefined one. But it's on average. So one block might be quicker, one block might be slower, right? So that you cannot have precise times within the blockchain. So that's why you have a precise number of the blocks. Yeah, so that's where you got this topic 0 from. Mm. Yeah, so that's where you get it. And then, as I have said, you can use the combination of those, making your example more complicated. Right? So, okay, we've discussed this thing here. It will help you to do time-based automations, and I've shared the materials that you might need for that. Now let's go to my favorite demo so far, which is stop order. It's my favorite because on the one hand, it's rather simple. On the other hand, it demonstrates the workflow that's actually usable, right? That actually makes business sense, so to say. And also because it's already in use by, like if you want to touch it as a, not as a developer, but as a user, you might want to go here to Reactify. This is the app built on reactive contracts that allows you to use this automation as an end user. So you won't even need, so you can share it with your friends actually who are encrypted but who are not developers, because you don't need to be a developer to use it. You just need to be to have a wallet with some funds and the desire to use stop loss take profit. So it works. You can use it actually on Base and Ethereum, but you can try it also on testnets. So yeah, but that's why I love this example, because it's practical. It's already in use. So let me go to back to my IDE. Uniswap v2 stop order, right? As a matter of fact, if you want to develop any reactive smart contracts, I suggest that you at least deploy the basic demo that we discussed earlier and the Uniswap demo that we're discussing now. It has a bit more steps, but it gives you a better understanding of what you're going to deal with when you develop actual reactive contracts, because you will have a more complex callback contract setup there, and because your reactions they are actually practical, not just to trigger an event to see how it works as in basic example. So yeah, obviously a README here as well with all the steps described. I don't think we will need to go over that right now, and I won't be deploying that live because it's a bunch of steps and I will need to wait after every step, and it's just not very good thing to demonstrate on video, on a call, but it is a good thing to go through yourself to follow all those steps. So I encourage you to try it. It's pretty cool, honestly. But yeah, I will discuss the contracts with you. So in that setup, we have several contracts. First of all, it's two tokens, which are basically ERC20 tokens. So there's literally no addition. Here, it's a simple ERC. It's a standard ERC20 token from Open Zeppelin library, right? So there is two tokens. There is a Uniswap version 2 pair. So basically a pool where the swaps are done between two tokens. And I don't even think we have a code for that here because we're using, so if you follow this demo here, you will be using an existing contract factory by Uniswap on Ethereum Sepolia. So that means that when you call this factory, right, you will be creating a Uniswap pool for your two tokens, and it's basically Uniswap code, Uniswap version 2 code. So you don't even need to write that code. It's like already there, right? So that's why we don't have it here. Then we have a reactive contract, and then we have a callback contract, right? So the origin contract, which is on the left on our scheme that I showed, it will be this Uniswap pair with those two tokens. Then the reactive contract we will discuss, and the callback contract we will discuss, right? Also, this setup, it's not cross-chain. It's for automation and for modularity, but it's within one chain from the business standpoint. So if we're talking about testnet, it will be just on Ethereum Sepolia, for instance, but obviously there is working Ethereum V2, Ethereum Uniswap V2 pools on the mainnet, which means you will be able to use that on mainnet as well, right? Um, yeah, sorry, I lost what I was talking about. Give me a moment. Yeah. So the origin contract and the callback and like the contract with which our callback contract will interact. It's the same pair that we will deploy using factory, and it's on the same chain on Sepolia. So it's if you remember the first slide, actually let me show it. Yeah, actually let me show both of those slides. So this one, in that example, we are doing automation and we are doing modularity. We are not doing cross-chain functionality. So this is the Uniswap pair that we will be using. This is the reactive contract, and this will be our callback contract, which in turn will interact with this pair here. Okay, so the reactive contract, as you can see, it's inherited from our abstract reactive, right? It does some simple stuff. So basically, it has the Sepolia chain ID hard-coded here. It has Uniswap version 2 sync, topic 0 here. So this is the topic 0 for the sync event. And sync event is the event that is emitted when there is a change of an exchange rate on a Uniswap pair. So we will be monitoring those events for the exchange rate, right? Then stop order stop topic 0. This is the event that we will emit after our stop order is executed because we don't want to run the monitoring forever. We will execute this stop order when the predefined price is reached, and we will stop monitoring after that. So these are the two topic 0 that we need. And yeah, we've discussed it earlier. So a bunch of variables here, they're pretty self-explanatory, triggered, done, pair, stop order, client, token 0, coefficient, and threshold. These two are basically to specify the exchange rate that we will be executing stop order at. I won't go into math here. It's into math of this thing. It's pretty simple. So you can read the contract yourself and understand, but I will go through the control diagram, so to say, right? So we'll go through this thing here and understand what happens after what. Okay, so this is the constructor. Obviously, it is executed when we deploy a contract. So it subscribes to the pair, to the sync event, and it subscribes to our callback contract to the stop event, right? So this is the reaction. Um, it's called when a one of the two events of interest are emitted, right? So we are subscribed to two events on two different contracts, a sync event and a stop event. Whenever one of those happen, the reaction is executed. Right, so first of all, we check that the automation is not done yet, right? Then we have the if where we see which one is the case, whether it's the stop event or the sync event, right? So for stop event, we go in this branch of if, and for sync event, we go to this branch of if, right? So logically, this goes first. So let's go here, right? So it takes a look at this sync event and it checks whether it's below threshold. So whether the price of interest is reached here and whether it has already been triggered here, right? Let's take a look at below threshold right away. So yeah, this simple math is done here. Then, if both those conditions are met, then we go into actual execution. So first of all, we emit the event. Don't confuse these two. So this is the actual callback, right? This one. This emit callback is a keyword in reactive contract. It executes the callback on the destination contract. And this thing here, it's just a usual EVM event, right? So it emits a callback event. So this is the payload for our callback. So this is basically what we're executing on the destination chain on our callback contract. We are calling the stop function. So this first thing is the address that we mentioned in authorization, right? We'll see it later. But this thing here, it will be replaced with our RVM address. So we only pass address 0 here as an argument because it will be replaced anyway, right? So this thing here is the pair address, then the client address, then the Boolean, which stands for which token we're exchanging for which. We'll discuss it later. And then the coefficient and the threshold that specify the exchange rate, right? So we form this callback here, passing all the parameters. Then we change the state, and then we emit the callback. So basically here, we are calling the destination contract. And as you can see, we've just walked through the whole reactive contract. As you can see, it's pretty simple. It was only like 129 lines of code, and we've just read all of it basically, right? So it's rather simple. In many cases, all the complexity will be shifted to the callback contract because the reactive contract will be only handling the automation. So monitoring the events, then checking some simple conditions, and then calling the callback. So in our case, the actual execution is described here in this function on the callback contract. So yeah, let's go to the callback contract now. Yeah, as you can see, it's inherited from abstract callback. And as you remember, as a matter of fact, let's take a look at it once again. Yeah, that's from our lib, which is also inherited from pair. So it has all the payment functionality because we need to pay for the callbacks as well, right? Then yeah, as you can see, it's pretty simple. What we're interested in here is this modifier right here, because we will be checking that it's our EVM that is trying to execute this callback. RVM ID only means it's only accepting the callbacks from with the specified RVM ID. So as you remember, our RVM ID is our deploy address. So the address that we deployed, from which we deployed reactive contracts on reactive network, it's our RVM ID. So basically here we're checking that it's our reactive contract that is sending this callback. Okay, so let's go back to our main contract here, which is callback, right? Okay, so it's inherited from abstract callback. That's why we have this feature for authorization. It has this stop event for terminating the monitoring after the automation is executed. It has a deadline as well. In a constructor, as you can see, it just gets the router where we're getting the Uniswap version 2 router that's related to the spare, right? Then we have this function stop, and I don't think we have anything else. Yeah, we just have this below threshold special function here. But basically, after we discuss the stop function, we will understand the whole contract. I'm telling you this because, as you can see, this function is not super simple, but it's also not complex. So after we understand this, we understand everything, right? So this is the function that we call in here in reactive contract. Let me show it to you again. Here it is, right? Then the first thing here is checked by this modifier, right? So this modifier here, it checks the first argument and makes sure it's our RVM, right? Uh, then the second is the pair address, the third is the client address, the fourth is the Boolean, which token, like whether we send selling token A and buying token B, or buying token A and selling token B. So since it's two tokens participating in this exchange, we're specifying which is what is the direction of this exchange, right? And the threshold. Okay. So now let's go through this function here. First, we are taking the first token, right? We're treating as a Uniswap pair. No, we're taking the address of the token A, the address of the token B, right? Then we get the reserves for token A and token B in the pair of interest, making sure the price is what we want, right? Then we require that our reserves below threshold, our price is below threshold. We do this calculation based on the reserves in this pair, right? So as you know, in the Uniswap pair, we have reserves for token A and token B, and those reserves is what defines the exchange rate, right? So we take these reserves, calculate the exchange rate, and make sure it's below the threshold. It's done in this below threshold function here. I suggest that you check the math and understand it yourself. Okay, so here we make sure that the rate is below threshold. Otherwise, we are quitting the execution with this warning. Then this is the token to sell. As you can see, our Boolean is token 0, specifies whether it's token 0 or token 1. This is the token we sell. This is the token we buy. Also, we take a look at the allowance, right? Allowance for the token that we're selling by the client that is using this automation to the address of this contract. So this might be one of the important parts. Let me slow down here. So this is the address of this callback contract that we are discussing right now, right? This callback contract will be doing some actions with the token of the client, right? Thus, the client needs to allow the token to be spent by this contract. If we go to README, we will see it in the steps that we will allow tokens to be spent, right? And if we use it in a Reactify, you will see like the additional transaction where you allow the tokens to be spent by the callback contract. But generally, it's the same thing you do when you exchange the funds on a DEX yourself. When you're using a pool on a DEX, you first allow your tokens to be spent by this pool, because that's how it works with ERC20 tokens, right? So here we are making sure that this callback contract has an allowance to spend the token that we're selling from the client's address. So, and here we're making sure that this allowance is more than 0, right? Then here we're checking that the user actually has this balance, right? Because we need to not only to allow the tokens to be spent, but also to actually have these tokens at the moment of the exchange, right? And then we do the transfer from. So we transfer tokens from client to this contract, right, that we are in right now, and for this value of the allowance, right? Because we won't be doing the swap from the address of the user. We will be doing the swap from the address of the contract because this is how the swap function works. That's why we first need to transfer the tokens from the user to the callback contract. Then the next step, we approve the tokens to be spent by the Uniswap, right? And this is the allowance. And then we execute the actual swap. So we take the path variable, we form the path variable that we will be putting into this swap, right? This will be the token that we sell. This is the token that we buy. These are the addresses of the token, right? And then we are executing the actual swap. So the swap is happening here on this line after all those checks and after transferring the tokens from the client to the callback contract address, right? Now, yeah, also we have the deadline. Now this is the swap. The swap happens, which means we're selling the token that we sell to the pair and we buying the token that we buy. So we're getting the token that we buy from the pool, right? So now, after this swap, we don't have the token that we sell anymore on this contract address, the callback contract address. But now we do have the contract that the token that we buy, and it's on this contract address, callback contract address. So what do we need to do? We need to transfer it back to the client because it's the client that who wants to get the tokens, right? So that's why we take this token buy and we transfer it back to the client. And that's it. After that, the swap is done. So that's why we also emit the stop event that means that the swap is done. Okay, the swap is done. We don't need to be monitoring the price anymore. So that's why the reactive contract, it catches this event here, right? And executes this thing here. So if this thing here is the address, is the event, the stop event from the callback contract, then that's what's happening. Done is true, and for the debugging purposes, done event is emitted. After that, the whole workflow has been executed. So what happened? Let's go through this once again. The pair, the Uniswap pair, emitted the sync event. This sync event was caught here. The conditions were checked by the reactive contract, and the stop function of the callback contract was called. Then we go to callback contract. This stop function is executed. We check some conditions, gets token A from the user to this contract, swaps token A for token B, and sends the token B back to the client and emits the stop event. And after that, the reactive contract, it catches the stop event here and stops monitoring, and that's it. Yep, and this is basically, I think this demonstrates perfectly how you can use reactive contract in a live setup, because even though this example is simplified, you can see like several warnings here, but generally it's not only a viable proof of C, I would say it's pretty close to a production solution because it also has the authorization checks here, and it basically it's usable for real applications. If you want something even more real, you want to go to this advanced version, but as I have said before, we probably don't have the time for this today. So yeah, I think I will make a pause here and wait for some questions.
Okay, thank you, Ivan, for the great presentation. Now let's move into the Q&A part. If you guys have any questions, please feel free to put them in the chat box or unmute yourself and ask directly. 大家有什么问题可以看到 Phoenix 有一个。Hello, Ivan. We have a question I want to ask you. After triggering the stop loss, will the entire monitoring session end?
Yes. As we've seen with this stop event, the monitoring session will end.
Okay, thank you for your answer. 还有同学有问题吗？可以直接开麦和疑问交流。You can unmute yourself and ask directly. 如果大家没有什么问题的话，那我们今天的 workshop 就到这里了。Alright, that's all for today. Thank you again to Evan for the great sharing, and thank you everyone for joining us today.
Yeah,
We will
thank you very
we
much.
really appreciate your time and participation. Have a great evening and see you next time. Good
Thank you. Have a
night.
great evening. Take care.